Okay, Assalamu alaikum. Welcome all to day 6 of this electrical safety specialist course. In the last session, we discussed about that there could be number of contributing factors to arc flash and R plus. So if you haven't given an opportunity to carry out the root cause analysis of this type of incident which have happened in your organization, um, try to look beyond 70E non-compliance. So all the incident energy, all the R flash and R plus incident might not have resulted due to uh, due to 70E non-compliance, but there are other factors which also contribute to those incident. So if there is if any person was working on that particular equipment and some incident happened related to R flash and R plus, then you can start your investigation or root cause analysis and identification. um, why 70E, whether the person was qualified, whether it was allowed to perform the live task, why the person was performing or interacting with that particular equipment while the system was energized, etc. and etc. Otherwise, if there was no interaction remotely or locally, then you have to check the non-compliance against 70E, 70B or NEC non-compliance. For example, whether the equipment was correctly selected for that particular area, it was complying with the installation requirement or not, or whether the equipment was correctly maintained over the period of time as per the 70B, as per the 70B uh, standard. Okay. And we can also check the non-compliance against the 70E from the qualified person point of view. So what does this mean from the qualified person's point of view? It means that a qualified person, because we have seen attributes of qualified person in our previous classes. Let me take you to that. So these are the attributes, or these are the skills a person should have in order to become qualified. So specific hazard associated with electrical energy or the equipment. So that person should know whether the electrical equipment is correctly installed, whether it has been maintained over the period of time correctly or not, etc. So due to this reasons, some of the factors which we have discussed also becomes necessary for qualified person to pick from. So 70E non-compliance from qualified person's point of view: accidental contact, dropping tools, human error, faulty equipment. Qualified person not should identify before working. Poor preventive maintenance, whether the equipment have been maintained over the period of time and why he is interacting with those equipment, electrical equipment and system design itself, etc. So these are basically from the point of view of the qualified person. Right, then we discuss about the life cycle activities. So just start a group discussion within your organization that how you are basically trying to identify those incidents there. So how well electrical asset lifecycle activities includes electrical safety requirement as a decision-making criteria. So normally this perspective is from the technical uh, from the technical angle or the lens, but you can provide it or you can see it from the HSCQ perspective as well, that whether those decisions are being considered which will going to have impact on the human safety at later stage of the life cycle activities. For example, now we know that if we are only designing our electrical system based on available short circuit current, the maximum available short circuit current, and we are not looking into the fact that what will be the available incident energy at that particular location. So we are basically more focused on saving our electrical equipment rather than doing things for human safety. So when we are designing electrical network, we do take into the consideration what is the short circuit level. Okay. So based on the available short circuit level, we basically select our electrical equipment. For example, at a particular location, if the short circuit current is 25 kiloampere, for example, so we will be selecting our switch gear, our equipment, which have the capability uh, to see 25 kiloampere minimum, or maybe 30 kiloampere short, or which can withstand 30 kiloampere for 1 second to 2 seconds, for example. So basically, equipment selection is based on available short circuit current. But there is another factor now. We have seen that from there is an incident energy as well. So at that particular location, what's the incident energy available? Normally, right now, organizations are not carrying out that additional step. So the calculation for the incident energy comes after you have calculated the short circuit current in your system. So there is an additional money, there is an additional scope requirement that you will be asking your consultant to provide you those studies as well. Okay. So in that particular case, now you know this information. You can you can talk to your technical team that, okay, you are performing this study. Why you are not going for this one, additional one? Because we will be the people who will be taking care of this asset for next 35-40 years, and we will be the one who have to uh, develop the policies, procedure, operating procedures, etc. and etc. So how will electrical asset lifecycle activities include electrical safety requirement as a decision making criteria? So here electrical lifecycle activities includes identification of the need, designing, planning, designing, then purchase. So okay, if the consultant has come that he cannot design system with less than 12 cals or 20 cals per centimeter square of incident energy. So being an HSEQ person, then you can talk to them why you are, then propose us an arc resistance switchgear. So what is an arc resistance switchgear? Let me show you one picture, then we will move on if you have not seen before. So if we go into the picture of the arc resistance switchgear, so this they basically differ from normal metal clad switchgear. In the metal clad switchgear, you won't find this chimney, which is at the top, or which will be have a direction at the back. So if any person is working in front of it and performing some switching operation, and if there is some flashover, so the incident energy will be directed towards him. So that is basically a normal metal clad switchgear, or a normal switchgear. But if you have this arc resistance switchgear, which is a bit costly as compared to your metal clad switchgear, so it, due to any internal arc, or due to malfunction or operation, the incident energy, or the energy which will be generated during an arcing event will not be coming towards the person itself. It will be directed upward through this chimney, and will be going uh, in the air. So this arc resistance switchgear basically redirect the energy which is released during an arcing event, or the fault condition. Yes, any question on this one? The function of an arc resistance switchgear? No, all good. So now you can talk to your consultant, or your owner, that why it is good to expend, or to spend more money on selecting, purchasing, and installing the high cost equipment as compared to your normal metal clad switchgear, due to this reason. Then another thing, is there any feedback integrated process established for reporting gaps in the lifecycle activities which might breach electrical safety standard? So those people who are performing work in operation and maintenance, are they able to communicate back to the people who are involved in the standard writing of the company, or who are involved in the procurement decision, who are involved in technical evaluation of the electrical equipment, who are they taking care of the safety measures while they are technically evaluating the electrical equipment and the installation? So I remember when I was working with one of the company back in Yambo in Saudi Arabia. So we had a lot of number of rotary type of the switchgear. So from the field operation, they provided the feedback that during the operation of those rotary switchgear, there is a chances of arcing and flashover is there, because they are now have aged and become old, and there is some alignment issue is there. So if you are not operating that particular switchgear in a particular manner, so there is a chances of arcing over or flashover is there. So the company policy then it was like that we will going to remove all those type of the equipment, and those type of the equipment won't be purchased in the future. So HSEQ people can play their part in those things as well. Is there any incident occur in your organization which was due to reason other than the human error? So which was other than due to NFPA 70E non-compliance? Just try to now go and talk and try to find out the R flash and R blast event which have occurred previously. Are there any other reasons than the than this one? Right. Any questions on this one up till now?
Sir.
All good. Yes, Jazeb, Mubin, all good.
We are talking about short circuit, right?
Sorry,
Short
Zishan, your
circuiting. I
voice.
had some 2-3 questions regarding short circuit.
Yes, please.
One is for CT transformer, we do short circuit, short circuiting in some stage, and then there is. Sorry, now it will be okay. Yeah.
Yeah, no, it's
So
fine.
for CT transformer, we do short circuiting.
No, again, we have lost your voice. Hello. Sorry, Zishan, you are not audible. You are muted. Okay.
Can I, sir, now? Is it
Yeah,
okay?
yeah, now it's okay.
So I had question for a short circuit, like for a CT transformer, we do short circuiting. Okay. And then there is uh, short circuit and then fault. One is short circuit and secondly was the fault current. So sometime we limit the fault current any towards the grounding. We add kind of resistance. And yeah, I think these are two questions. And
Basically,
how
short
much?
the CT secondary is short circuited if it is not in use, because it is due to the construction of the CT itself that the voltage builds up if you are not using the CT. So voltage will going to build up on the secondary, and it will going to reach in kV level, that if any person is in nearby, he can be electrocuted. So this is short circuiting the secondary of the CTs when not in use. So this is due to its construction thing. Okay, here it the shorting the terminal of the CT will not be causing fault in the CT, but it is for the protection of the people. Secondly, there are different type of the grounding arrangements. Somewhere we are grounding solidly grounding the neutral or the earth or or sometimes we are grounding it through the resistance. So those are basically the design parameters, and it has been calculated that how much amount of fault current you want in so that your protection systems can operate accordingly. So in some cases, if you are solidly grounding your electrical equipment, it might cause a huge amount of fault current to flow in a shortest amount of time. That may cause damage to the electrical equipment. On the other hand, if you are grounding it through the resistance, so that is will going to limit the fault current, which is basically flowing through the neutral or which is flowing through the ground path which have been created for that current, so that your electrical equipment and installation remains safe. Yes, Ishan, am I able to answer your queries?
Yes, sir. Yes, sir. That's okay.
Okay, let's move to whenever an employee is interacting with electrical equipment under normal operating condition for establishing an electrically safe work condition, they are at a risk of high injury. Okay, so what's your opinion? Yes, whenever an employee is interacting with electrical equipment under normal operating condition for establishing an electrically safe work condition, they are at high risk of injury. The answer is disagree. It's not right. We have discussed that under normal operating condition, when the equipment is properly installed, properly maintained, there is no evidence of impending failure. The doors are closed, the doors are secured. So those are basically the normal operating condition as defined by the NFPA 70 and article under 10.4D. So under that condition, the employee is not in risk. He can operate that particular equipment safely. Okay, that point we will going to discuss in our module number 2, when we will go to streamline everything. Right now, I'm just making your concepts based on complete standard. So when we will start to go page by page, word by word, you will know, okay, we have already discussed, we have made this concept, or it is referred here in the standard. So just keep this in mind, that under normal operating condition, the people are safe. There is no chances of arc flash. There is no chances of flashover. And the people can perform their job safely. Yep, the equipment condition considered to be normal if all the circumstances apply. The equipment is properly installed. The equipment is properly maintained as per the manufacturer recommendation and applicable standards and codes. The equipment is used in accordance with the instruction. The equipment doors are closed. The equipment covers are in place. There is no evidence of impending failure such as arcing, overheating, loose bound, etc. So what is NFPA 70? NFPA 70 is about protecting the employee. Option number A is the right option. What is the purpose of NFPA 70? To provide practical safe working area related to the electrical hazards. So this is something which we have discussed. We have tried to make the concept up till now. The NAC addresses electrical installation requirement and provide for safe operation of installed electrical equipment. What's your opinion on this one? Yeah, so this statement is agree, it's okay. NEC addresses the electrical installation requirements and provide for safe operation of installed electrical equipment. And in some cases, it also take into the consideration the selection of electrical equipment for the for the designated thing. Yani if you want to select an electrical equipment for particular area, NEC will going to guide you. NFPA 70E applies to yeah, the right answer is option number B. A is not the right answer, or all employees, because for all employees who are not interacting with electrical equipment, so who are not performing operation maintenance, it's not a NFPA 70E responsibility to protect them. It's the responsibility of NEC as well as it's the responsibility of 70B to take action. So all employees exposed to electrical hazard not addressed by the installation requirement means all employees who are exposed to electrical hazard which is not basically answered by NEC requirement. So we have seen one picture in which in which the breaker were installed and no one was interacting. When you open uh, that MCB or the panel in order to see if there is any switch have or if any fuse have blown, or if there is any short circuit have happened, etc. and etc. So then the responsibility shifted from NEC to NFPA 70E. So NFPA 70E is responsible for all employees who are exposed to electrical hazard which are not which is not addressed by the installation requirement. So now 70E will going to apply for all qualified and unqualified employees who will be uh, around that particular working area. So the requirement for limited approach boundary, restricted approach boundary, and R-flash boundary creation awareness, whether you have to perform the job after establishing an electrically safe work condition, or you have to perform the job live, etc. and etc. All those things will be applicable. So those will be applicable as a part of the NFPA 70E um, uh, requirements or the standards. Yeah, am I able to clarify this point? Okay. 70E applies to all employees exposed to electrical hazards. So another thing you have to take care in the exam, whenever 70E talks about all employees will going to cover qualified as well as unqualified employees. Okay, so in most cases in exam they will going to be very specific if they are talking about qualified or unqualified employees. Uh, on the other hand, if they are talking or if they are using the term of employees or all employees, then it will mean that they are talking about both, right? Okay, moving to another question. 70B address electrical safety of employees when they are interacting with electrical equipment in manner other than the normal operation. Sorry. Yep. Next one. This is an agree statement because all the requirements of NFPA 70 is applied when the the equipment is not considered under normal operating condition. So we have seen that if the equipment is considered under normal operating condition, that means equipment has been properly maintained, it has been installed correctly, there is no evidence of impending failure, no doors are open, etc. and etc. So 70E requirements are not in place. There is no requirement to create arc flash boundary, shock protection boundary. There is no requirement to carry out the risk assessment, shock risk assessment, arc flash risk assessment, and the person who is performing the job is not required to wear any PPE as well. Even it's not required to fill and energize electric work permit. So having said this, that means if the equipment is under normal operating condition, those are not required. But if the equipment is considered under abnormal operating condition or not normal condition, then 70E requirements comes in action, which is about safe work practices which have been defined in the standard. Yeah, this question and explanation is clear. Yes, Mr. Zishan, does this make sense? Please confirm so that we can move.
Yes, sir.
Okay. So these are some of the building blocks or the concept. As per 70, human error is the major contributor in the cause of injuries. So the answer is yes, because 70E takes into the consideration that even if you have developed policies, procedures, you have trained your people, you have provided them the best personal protective equipment, PPEs, and other things, it's still incidents happens, and then why incidents happen is due to the human error. That's why you will going to find in the standard a complete sorry, I was muted. So that's why you will going to find a complete annexure in NFPA 70 related to the human error. Let me take you to that annexure. Human performance and workplace electric safety. No, dropping tool is not the one human error. Bypassing the policies procedure directly, intentionally or unintentionally, is human error. Not identifying the state of the electrical system, whether there is an impending failure, or not, and interacting with that particular equipment, that will going to fall under the human error. Not following the correct work practices and the procedure is the human error. For example, it's clearly mentioned that you cannot parallel these two lines or these two circuits. If you want to switch over, first you will going to put off from one side, and then you will going to put on the another side, so that the ring are not operated in parallel, but the person has operated, has energized both the thing in parallel. So there could be number of things which can come under human error. For example, while re-energization, they have not removed the grounding first, and they try to put on the supply. So all those things will going to come under the human error. You have not established an electrically safe work condition. For example, there is a requirement of carrying out verification for the absence of voltage, but you have bypassed, and the person directly goes to try to do the ground and short. That will going to fall under the human error as well. Right, I have to also pray Maghrib. Can we take 5 minutes break now for Maghrib prayers? Mubin will be going for Isha, which might take a bit long. So let's take 5 minutes break. I will pray Asr here. It's Asr time. Okay. in recording. So basically, what's the main difference between the earthing and grounding? So different type of the earthing studies are being used. Electrical system is basically earth by designing earth mass system or other type of the system. In that system, we are doing a study that in case of fault in our system, what will be an earth potential rise that is calculated in voltage level. So if the earth potential rise is greater than 400 volts or 600 volt for high efficient system and high tripping system, that won't be considered as a safe design. So in normal in grid station in LV network, we try to reduce our earth potential rise EPR less than 430 volts in here in UK. So if it is 120 volts, 60 volts, 80 volts, that means the site is cold. Site is cold means that in case of any fault occurring in that system, the voltage will not going to rise in till that point, and no one will be electrocuted, whether they are performing job or whether they are in that particular area. So in doing the earthing, what we actually do, we calculate how much earthing rod or the grounding rod. Those are basically used as a alternative, but the right term is to use the earthing rod. What will be the size of the earthing rod, diameter of the earthing rod, what should be the cable size used for designing the earthing system, what should be the length of that cable. So those things we calculate, and basically we connect those things, the earthing with the electrical system. Okay, so that is basically the earthing. Grounding is normally used with the system, so that if there is some unbalancing is there, it can ground those unbalanced current, or like NGR is called neutral resistance grounding. So if there is unbalance in the system, there will be current will be flowing through our neutral, and that neutral will be grounded. The current will be grounded safely. So grounding is primarily used for unbalancing when an electrical system overloads, or electrical system there is some difference in the three-phase systems there. Okay.
All right. All right. So exactly is the definition from OSHA as well. Yeah, as you mentioned. Yeah.
So earthing is basically used to protect
To
people from electric
exactly.
shock. Okay.
Yeah.
So earthing system is for
Earth-
human protection. Grounding system, you can say it's for the protection of the electrical system or the equipment itself.
Okay, sir. Now there are two more quick connected questions. One
Yeah.
is equipment grounding and one is system grounding. So I can like the same statement can be like is I can like use for the equipment and system grounding. The same, right? Because we do equipment grounding like for our protection and system grounding
Yeah.
for the protection of equipment. So goes the same way, right?
Yeah, equipment grounding, you can term is as that you are basically protecting.
Earthing.
Yeah, and
Okay.
system grounding is like that. In case of an any failure or anything, it will going to cause the the current to flow through the ground, and it will going to basically trip
Mm,
the circuit breakers. So that
yeah.
is the circuit part which we are creating.
Okay. So one last statement. If we say main grounding and then we have what we call it additional or protective grounding. So is there some can we call this the normal grounding? Can we call it main grounding and the other grounding as protective grounding? And is there some difference between the both?
These might be different type of the statements being used, main grounding, or I've not heard like this type of the thing. Maybe you are asking it from the HSCQ point of view or from the technical point of view.
from the middle any of the both.
Yeah. So electrical circuit or system grounding or electrical equipment grounding. So these are basically the two type of the grounding having different intentions.
Okay.
Okay, so we have seen that basically the electrical, if we talk about the equipment grounding, it is for the safety, that in case of failure or fault, there will not be basically it will be safe for the people. And if there's some fault in the system, then that current will going to flow uh, through the grounding, and it will going to help to actuate the protection system.
Okay. So I can say, is there any difference between grounding and protective grounding?
I cannot comment on this one. What is mean by the protective grounding? Basically,
Protective
grounding.
grounding is like temporary grounding.
This might is there any reference to any standard terminology which you are using from?
Temporary grounding is, for example, if there is a work on our headline, so what you do, you ground like from
Okay.
the both.
Yeah.
So
So that is basically you are doing
upstream.
grounding on the de-energized system
Yeah,
or this.
exactly,
Okay, so
exactly.
that protective grounding, it's for the system, which is you have put into an electrically safe work condition, and you are protecting it that in case of re-energization or some or maybe due to close proximity of two circuits, that circuit becomes energized. So the additional current will going to pass through that protective grounding into the ground, and will going to cause the circuit breaker to trip.
And that help. I think the protective grounding that help to discharge the remaining energy or the residual, what we call. Uh,
Yes. So
yeah,
in the
stored in.
circuits, if in like for example, if you are if you are creating an electrical say work condition for a cable, so there is a residual charges remains in the cable. So first you have to discharge those cables, and then you ground them. For the capacitor, you are also discharging those residual charges by using your grounding methodology. So that can be used to discharge the remaining residual energy quickly as well.
Thank you so much.
Okay, let me find some OSHA. Yeah, Janzeb has also provided some references. I will search if there is some information available on online as well. Okay, moving forward, electrical power generation, transmission, distribution. Yep, 192269. Okay, so energized means electrical connected or to a source of voltage. This is from article definition number 70, article 100. So the term energized is associated with all voltage level, not just those voltage level that presents a shock. So we have seen that 50 volts and above represent a shock. But if you are interacting with any electrical equipment and system which is below 50 volts, so it will be termed as an energized. There will be no potential for electric shock, but still it will be considered as an energized network. Energized equipment and devices are not limited to those that are connected to a source of electricity. Batteries, capacitor circuits with induced voltage and photovoltaic system must also be considered energized. In addition, electrolytic processes are considered as an energized system. So in the electrolytic process, we know that if you want to de-energize system, either you have to remove the material or the electrode itself or the electrolysis which is uh, within that. Right. Where does an arc flash hazard exist? Knowledge check. Certainly a knowledge check have come. Yeah, fluid. I was missing the terminology. Yeah, where does arc flash hazard exist? There will be two options correct. Yeah, B and C are the right answer. For exposed conductor and circuit parts and during interaction, for example, racking in or racket out of the circuit breaker. So B and C are the right answers. The magnitude and severity of energy released during an arcing incidents are directly related to. Right, so the magnitude and severity of energy released during an yes, any question? Okay. The magnitude and severity of energy released during an arcing incident are directly related to arcing current and the fault clearance time. So the question is talking about the incident energy released, or the question is asking about the magnitude and severity of energy release. It's not talking about the incident energy. So energy released will be based on A, okay, arcing current and fault clearance time. If the question was the magnitude and severity of incident energy, then we would have included the working distance as well. So then in that particular case, A, B, both would have been the right answer for the incident energy, because the greater the distance, the lesser will be the incident energy. On the other hand, it's if it's talking about the magnitude and severity of the energy release, then the option number A is the right option. Okay, does this make sense?
Excuse
All
me,
good?
sir.
Okay.
Excuse me.
Yeah, please.
Excuse me. Yeah. Sir, in case if it was incident energy, but still it is about the source, right? And if it is directly related, that means that it will incident energy is something like from the source or the impact on us.
And
If
for
it's
the
something,
for the incident energy, it will going to cover both. It will
okay.
be dependent on both the arcing current, fault clearance time, and the working distance. So just remember the table in which the PP category table. So the PP category table talks about the fault current, the device clearance time, and the working distance. So that's how we are calculating the incident energy. But the energy released from here, from this equipment, it will going to depend upon the available fault current and the fault clearance time, and the energy which is reaching to this person, the incident energy, will be dependent on the working distance. If this person is sitting 10 feet away, the incident energy will be only 1.2 cals per centimeter square. But if he's working at the face of this electrical equipment, the incident energy might be 40 cals per centimeter square. Okay. The arc rating on PP, select all that apply. Mhm. What Mubin has said, the incident energy of an arc flash depend on how much current is available, how quickly that current can be shut off. Yeah. And how quickly that current can be shut off and how far. Yeah, incident energy is depend on the city found on the ATR. What is this ATR? Yes, Mubin, what does ATR means? Okay, American Training Resource. This is one of the issues I'm really facing with the Britishers. They use so much acronyms, considering that other person will going to know what this means. In my complete organization, they only talk about uh, in short forms, and I have been used of American accent, and this British accent is very difficult to understand. I might need classes from you, Mubin, and tips and help. What time you will be available for some casual chat? Okay, that's great. I want some resources to understand your accents. Like if you are talking to anyone who belongs to Yorkshire or who belongs to Scotland, you only doubt whether you have listened to English language before or not. And if you are talking to some Irish people, it's like what they were going to say that I only say yes, okay, thank you, bye. Okay, like is this right? That's great. Is what just funny side of this. Okay, American Training Resource ATR. Thanks a lot. Okay, arc rating on PP. Select all that apply. It does not provide you shock hazard. Okay, it will going to provide you the incident energy protection level and provides the electrocution probability. No, is expressed in cals per centimeter square. Yeah, B and D. B and D are the right answer. Okay. B and D is the right answer. Next one is authority having jurisdiction. It's like it could be a single person, organization, office, those who are responsible for enforcing the requirements of the code and standards like NFPA 70E, NEC, NFPA 70B, etc. for approving equipment, materials, installation, or procedure. So when it comes to the procedure, it could be working procedure as per the 70E requirement. Approving equipment and materials and installation could be NFPA 70 requirement, which is NEC. Okay, and this one, the procedure could be related to maintenance as well. Maintenance procedure, national grid, SAC and KSA. Yeah, it's like this. If anyone is interested in relocating, just text me. I have created some WhatsApp group. Okay, in which in that group we are helping people with job description and others. If anyone is looking, just text me. Okay, moving to other one. So this is an arc-rated head protective fabric that protects the neck and head area, except for a small portion of the facial area. These are designed to protect neck and head area, except for eyes, while others leaves this eyes and nose as also an unprotected area. This is also calculated in cals per centimeter square, and it is also as per the 70E requirement that's in. It is arc rated and basically it is measured in cals per centimeter square. So it is also tested as per the requirement of ASTM, right? Like ATPB or EBT. So all those tested will be applied in order to meet the requirements of NFPA 70. So what's the definition of the barricade? So this barricade could be greater than the limited approach boundary or the arc flash boundary, whichever is greater. Or it can be on the outermost circle, or then this limited approach boundary or the restricted approach. Sorry, limited approach boundary and the R flash boundary, whichever is greater. It can be equal to, or you can make barricade of that area greater than this particular area as well. So a physical obstruction such as tapes, cones, frame, tube, frame type, wood, material structure intended to provide warning and limit to access, those are basically used for the barricade or to barricade the area. What is the definition of the barrier? So barrier is something, a physical obstruction that is intended to prevent contact with equipment or energized electric conductor or circuit part. So barrier is basically the integral or is basically the part of the electrical equipment itself. Is there a standard reference for the type and color of barrier? 70 does not talk about those things. Okay, that what type of the type and color of the barrier used. So as for 70, there is no such thing. We have to refer it to other standards maybe for color combinations, but I've not seen that 70 is talking about that what type of the colors used to identify LV, HV. I think it's green, yellow, red, and blue. I will check if in the handbook they have mentioned any color coding, but I don't remember that there is some specific requirement related to color coding of the medication. Okay, maybe OSHA talks about this thing. If it is that the case, just share in the group. That will be helpful for me as well for future reference. Green safety, yellow warning, blue mandatory, red danger. Okay, so this could be in IOSH, NIBOSH, maybe not in IOSH, but in NIBOSH or other courses. But 70 does not talk about color representation of the hazards. Right. Then there is a definition of working on. So how we will going to define the working on? Working on is about the energized electric conductor or circuit part. Intentionally coming in contact with energized electric conductor or circuit part with hands, feet, or other part of the body, with tools, probes, or with test equipment, regardless of the personal protective equipment a person is wearing. So working on is categorized in two forms, like if you are performing some diagnostic test or if you are performing some repair or replacement. So for these two type of the activities, we will be intentionally coming in contact with energized electric conductor and circuit parts uh, uh, with our hands, with our feet, or using tools, probes, or even if we are coming in some close proximity. So that will also be considered as in working on. So there are two categories of the working on. Diagnostic is taking measurements, readings of electrical equipment conductors with approved test equipments, and the repair is related to the physical alteration of the electrical equipment or conductor or circuit part. That is if we are removing, replacing, tightening in any components or equipment. So these are some of the definitions which we have covered from Article 100 up till now. Okay, and there are smaller definitions also available, which you can understand just going through those as well. Okay, so as a part of your assignment, just go through these definitions. Okay. Here in 70, the ground and the earth, they are taking as a common. Okay, ground, the earth. Let's see what they are mentioning in earth. No, they have not defined earth here. The ground, they have mentioned earth only. or it's ground the earth. Grounding conductor, they have defined grounding electrode conductor. Okay. Right, so just go through this definitions, and if you have any questions on these definitions, which are around 60 to 70, just feel free to ask in coming sessions. So we have covered working distance, we have covered working on, we have seen difference between the metal clad switch gears and the arc resistance switch gears and other things as well. Right, any questions up till now? So in module number 2, we will going to start from article 105, and it will going to follow. Chapter number 2 will be based on article 105, 1010. Module number 3 will be based on article 120. Module number 4 and 5 will be based on article 130. So up till now, we have almost completed our module number 1. We have some Q&A, which we will going to do, and then we will start module number 2 if time permits. Okay, Ballot, what should you do if you find a person who is frozen to an energized electric surface or wire? Yeah, C is the right option. Turn off the power immediately and make sure that it is removed. Then to start with the other procedure. What is the first step toward protecting yourself from the many electrical hazard you face on the job? Yep, recognizing the hazard is the first step. A is the right option. To help you get the job done and prevent injuries, your employer sets up. We have not discussed this one, but it's good to have the knowledge of the terminology. Yeah, the right option is option number A, electrical safety program. So this we will going to discuss in article 110 and in module number 2. So to help you get the job done and prevent injury, your employer sets up an electrical safety program. Under that electrical safety program, all the things which I mentioned, those are part of your electrical safety program, ESP. Yep. Electrical safe work condition can be achieved by de-energizing electrical equipment only. So the answer is B. Yeah, it's false. It cannot be done if you are only de-energizing. You have to follow all Article 120.5 requirements. So the term de-energizing describes a condition of electrical equipment and should not be used for any other purpose. De-energize does not describe safe condition. Right. A quick overview out of OSHA and NFPA 70. So what is the difference between the OSHA and NFPA 70? OSHA stands for Occupational Safety, Health and Administration, a US federal government agency. So in this context, OSHA is basically a law. It's a mandatory requirement to follow, and it contains shell requirements. So the OSHA is a shell, and NFPA 70E is basically how. So OSHA will going to talk about in the performance-based requirement for safe work practices, how you will going to actually achieve that. For that you can follow NFPA 70E guidelines or any other electrical safety best practices available. So in US, it's a mandatory requirement to fulfill the OSHA requirement. But how you will going to comply with those, it's up to the employer. If employer thinks that NFPA 70E provides best practices and it answers all the questions which they have, so they will going to follow 70E or best practices, or they can follow any other best practice as well. So 70E guides employers how to achieve safe work practices tailored to help employers fulfill their OSHA requirements. So if you are following the 70E requirement, you can fulfill the OSHA responsibilities or the requirements as well. So in OSHA, there are some general duty clauses which is very high level, which talks about what employer should do, how the employer will going to do that. Those references are in NFPA 70. Yeah, every country has their own workplace safety standard. So NFPA 70E is most popular because other countries have not produced this type of the standard up till now. Even Australia and New Zealand are referring to NFPA 70E standard for best practices. So each employer shall furnish to each of his employee employment and a place of employment which are free from recognized hazard that are causing or likely to cause death or serious physical harm to his employees. So this is very generic type of the statement. This is a general duty clause, and this is basically the law. OSHA does not state how to comply with this clause, but NFPA 70E does. So in other part, like in standard 1910 subpart S addresses electrical safety requirements that are necessary for practical safeguarding of employee in their workplace, but still it does not answers the how you will going to do the incident energy analysis, what in different circumstances, what PPs you will going to wear, what should be the work practices related to the authorization of energized work as compared to other type of the work, etc. The standard 1926 subpart K addresses electrical safety requirements that are necessary for practical safeguarding of employee who are involved in the construction work. So subpart V covers the construction of electrical power transmission, distribution, and other type of the equipment requirement. 70E is not adopted by legislation. It is often used by employer voluntarily to help their obligations to OSHA. So this is agree or strongly agree statement. This is 70E is not adopted by legislation. It's not the mandatory requirement. But it's up to the employer whether they want to adopt it or not to fulfill the OSHA obligation, or they think that there are other type of the standards which will going to fulfill fulfill their obligations more in more easy manner. So the background originally developed at OSHA request, because OSHA have already published its general duty clause, its requirement, but the industry was asking that you have mandated something that we have to do it, but where is the industry guideline? How we will going to meet your obligations and the requirement? Then the OSHA request to NFPA to develop the standard for electrical safety. So it was established in 1976. NFPA 70 is not a law; it is recognized as a best practices. So there is a difference between a law and a best practices. Best practices, it's not mandatory to be adopted. Okay, you can pick some best practices from 70, other best practices from other uh, uh, other standards. For example, 70 2021 is the 11th edition of this series. So this edition has gone through so much reform, so much reviews. Now it is in its mature state. So now it is expanding its domain and trying to bring other topic of interest as well. In the previous editions, like in 2003, 5, 7, and 12 onwards, they were basically more towards developing the content standards which are applicable, and if something is not working, they were changing those standard requirements. Since 2015, I have been following this standard. I have gone through 15, 18, now 21. So in these three standards, there have been uh, more changes related to uh, addition of new thing and repositioning of text from one article to another article in order to make it more understandable or sensible to the readers. Um, Deleting some requirements which does not add any value or which were causing some confusion. So from 2018 to 2021, I have not felt much changes there. Yani there is some drastic changes in the concept have happened. No, it was more related to addition of one annexure, like they have added capacitors, working safely with around capacitor. That annexure have been added. They have updated annexure D, which was related to calculation of the incident energy. Previously, incident energy methodology adopts IEEE 1584/2002, where a method of calculating the incident energy, which is now updated to IEEE 1584/2018 reference. So those were there. There was shuffling of text from one place to another place, like they have moved uh, the priority of establishing an electric safe work condition from Article 130 to Article 105 there. So just to make sure that people understands that the first priority is about establishing an electric safe work condition, then going towards the awareness and another part. So now this standard is in mature. If you have a command on this standard, so if you are following this standard, so the next edition 2024 is also under review, and it will be released by mid of 2024 maybe. So in that edition, you won't be finding that much changes. Right. So Zishan is asking, so the shell statement in 70E are backing OSHA requirements? No, they are not backing OSHA requirements. It says that if you want to apply 70E in your organization and you want to get certified against that, you have adopted the 70E requirements. So you have to implement all those shell requirements which are stated in NFPA 70E. Otherwise, you can adopt the shell statements, some shell statement which are working for you, but you cannot you cannot get certified that you have adopted the 70E completely in your organization. I also don't know up till now whether there is some organization who are doing certification of the organization, just like ISO 45000, ISO 9000. No, those type of the certifications are not being provided by NFPA. So other type of the organization like Easy Power and similar type of the organization in USA are conducting gap analysis against the NFPA 70E best practices or the recommendation, and they are providing recommendation what documentation and the procedure you should have in your organization in order to comply with the 70E requirement, and they are issuing their own certificates or own certification. So there is no certifications right now at from the NFPA level or any ISO level related to NFPA 70E. So if you want to apply, or if you want to demonstrate that you are following the 70E requirements, you will going to fulfill all the shell requirement, and then you will be carrying out some audit, external audit from those organizations who can provide you certificate that your company comply with the 70E requirements. I don't know what value it will going to add, but certainly it to the stakeholder it will be like that you are following some best practices, and it is being that certificate is being provided by some credible organization. So for example, if the organization in which you are working, Zishan, for example, that takes the responsibility and it somehow talks to NFPA that we have certified CSP people, and we want to establish the electrical safety program in the organization, their trainings and etc. and etc. And we also want to be involved in the certification. So what type of the certification or things NFPA can provide in that particular case? Right. So up till now, there is no ISO type of the thing that this organization is certified or not. Is there some reference or checklist for electrical safety compliance? So you can develop your own checklist based on the based on the shell statements which we have, or and other which we will going to discuss as we move on with the course. So you can start to develop those shell statement, that those will be basically the requirements of 70. For example, uh, electrical equipment which are operating above 50 volt shall be put into an electrically safe work condition. So this is one of the requirements. So you can just paste this requirement as it is, as and refer it to clause of NFPA 70. So that if you develop your checklist like this, then it will be an final checklist which can be used for implementation and for as well as for the audit purpose as well. Okay. OSHA standard detail work procedures and practices that are solution to the general duty clause found in NFPA 70 standard. Okay, so the answer is false. OSHA standard does not contain detailed work practices and procedure. Those are basically covered in 70, and OSHA standard basically covered general duty clauses. OSHA does not provide specific requirements for complying with the general performance based rules. OSHA standard is written mainly in performance based language versus prescriptive based language of NFPA 70. Yeah, the answer is A. It's written in performance-based language versus the prescriptive-based language of 70. 70E is written in prescriptive or descriptive-based language. So it's A is the right answer. OSHA looks to the perspective-based requirements of NFPA 70 to fulfill performance-based requirements included in the standard. Right, NFPA 70 reduces risk under which of the following conditions? Yeah, answers please. 70 reduces the risk under abnormal conditions only. So B is the right option only. A, under normal condition, no, under normal condition, there is no risk. Or under normal condition, it's the responsibility of NEC or NFPA 70. So only under abnormal condition, the 70E will going to reduce the risk reduce the risk. Okay. Any question or comment on this one? B is the right answer. NFPA 70 address which of the following hazards? Yeah, so the blast hazard is not an R blast hazard. It's a blast hazard. So it's not covered here. So B is the right answer. Electrical hazard. So under electrical hazard, arc flash hazard, arc blast hazard, and thermal hazards all are covered. Shock hazard is also covered. The top priority for achieving the 70 is to this we did in the starting. The top priority for achieving the 70 is to create an electrically safe work condition. C is the right answer. Which part of NFPA 70 you can find safety related maintenance requirement? So the right answer is chapter number 2, B. In which part of NFPA 70 you can find safety related maintenance requirement? Chapter number 2. OSHA enforce NFPA 70. What's your opinion on this one? The answer is B, false. It does not enforce NFPA 70, you can adopt any standard. 70 standard for electrical safety in the workplace provides safety related work rules necessary to eliminate the electrical hazards. The answer is false. 70 not only does not talk about safety related work practices to eliminate the hazard. It talks about that if you are not being able to eliminate the hazard. So basically it talks about applying the hierarchy of risk control. So in the hierarchy of risk control, the elimination of the hazard is one thing, but it also talk about substitution method, engineering control, administrative control, etc. So the answer is false. Right. A quick review about 70E and IEEE 1584, how they are similar, or how IEEE 1584 is part of the Annexure D. So in Annexure D, you will going to find a different type of the methods to calculate the incident energy. One of the methods is IEEE 1584, which is now being used globally. So it has few steps like collect the system and installation data, determine the system modes of operation, whether it is being operated in island mode and connection mode, or with tiebreaker off, on, etc. Determine the bolted fault current, determine the arc fault current. So first you will going to find the maximum short circuit current, and based on that maximum circuit current, what will be an arc fault current. So arc fault current is always lesser than the bolted short circuit current due to additional resistance of the air medium through which arc fault actually develops. So the resistance is there in arc fault. So the value of the arc fault current is lesser as compared to the bolted fault current. Find a protective device characteristics and the duration of the arc. So device protection we will going to do. Document the system voltage and classes of the equipment. Select the working distance and determine the incident energy for all the equipment. So this one, the last step, is about the incident energy, and the final step is about arc flash boundary calculation. So we will be calculating, we will be inputting the working distance ourselves, whether at that particular location the working distance will be 18 inches, 24, 36, 50 watt inches will be there. So based on that working distance, we will be determining the incident energy for all the equipment as well as the arc flash boundary for that particular equipment. So basically this method, IEEE 1584 method, can be used to calculate the incident energy, arc flash boundary, and what could be the suitable working distance for working at that particular location. So this is how IEEE 1584, which is basically the guideline for performing arc flash hazard calculations, are being used. And Annexure D talks about this standard for calculation of the incident energy. This figure we have seen before. You can develop your and model your system on ETAP or any other softwares, and you can calculate the arc flash boundary, the incident energy, and other information which you require as a part of your arc flash risk assessment. Then moving towards the 70E scope, NFPA 70E scope. What is the scope of NFPA 70E? Now we have discussed about the general requirements. Okay. What's your opinion that NFPA 70E can be applicable to all type of the industries in which we are working, like generation, transmission, distribution, general industry, construction industries? Yes. What's your opinion? Yes or no, that NFPA 70E can be applied? Yeah, why no, Zishan and Mubin? Is there any technical part you are talking about that it cannot be applied? Yes, anyone can explain your answer? No. Yeah, as per, I'm not talking about scope right now of the standard, just as a part of our discussion up till now. So as per the discussion, we have seen that the 70E is applicable to, it can be applied to any type of the organization in which you are working, if for because the things are common, like establishing an electrically safe work condition, not allowing the energized work, doing the risk assessment, performing the shock and arc flash risk assessment, etc. and etc. But NFPA 70 standard, because it is a US based standard, you will going to find that in 90.2 they have specified that that this standard can only be applied to the customer side of the installation, or towards the load side of the service point. So that means the 70 is not applicable to distribution, transmission, and generation industry main equipment. But if you are tapping some high voltage or bulk supply from 132 kV, from 11 kV, etc., and that becomes the premises of the client, it the 70 can be applied. So 70E is not restricted by the voltage level. It is basically due to US internal bureaucratic system or their internal policy. That's why they are not allowing 70E to be applicable to distribution, transmission, generation companies. There is another standard, NESC, National Electric Safety Code, NESC, which is applicable for distribution, generation, and transmission companies there. So from the exam point of view, just bear that in mind, that you have to give your answer based on the scope given in 90.2. Okay, so in 90.2 it says that the NFPA 70E is not applicable um, to certain type of the industries. It is mostly applicable to generation and transmission industries, or within sorry, it is applicable to construction and general industries, and it is not is applicable to uh, installation in electrical power generation, which are basically the integral part of those electricity generation. For example, it is not applicable to the generating yani electrical power station generators, or for controlling of their turbine circuitry and other things. But 70E can be applied to warehouse, workshop, residential areas, uh, offices, building, administrative building of those generating plant. So buildings which are coming within the generation power plant, the 70E standard can be applied. If it is a workshop, warehouse, a store, etc., there can be 70E can be applied, but only 70 cannot be applied on those electrical equipment which are basically integral part of electrical generation installation itself. Not for are on the property owned or leased by. Yeah, those are basically. Yeah. So when you will going to read the handbook says that, however, if the employer determines that the required level of safety can be achieved by following the rules in this document, the employee is not stopped or is not yani, it's up to them. It's up to them. They can apply or they can follow the 70 requirements. So in the handbook, they have clarified this point that as per as per the scope, it is not applicable. But if the employer thinks, determine that the required level of safety can be achieved, they can follow the 70E requirements. But from the exam point of view, please bear in mind that those areas which are not covered, we have to give answer that those are not covered as per the scope of 70. So what are those area involved? Like generation, transmission, or distribution, or electrical energy. It's for communications, metering, like thing, boards, car, another type of the movement type of the equipment. Those are basically not covered as per as the part of the 70. Basically, handbook is the further explanation to what is given in the standard. Okay, so standard will not going to explain things in detail. The standard will going to define the requirements, and handbook is basically the translation or further explanation of the requirements, like tafsir and I should not compare, sorry, those things. Like someone have said something like their poetry, and other people are explaining what the poet wants to say. So standard will going to contain the requirements, stringent requirements, and the handbook is basically the explanation. Yeah, it could be application of the standard explanation and where how you can apply further. So in this picture, which I've taken from one of the trainings from 70, you can see that these are basically integral part of some generating facility. So those things which are used for controlling this integral equipment, this is not covered by 70, but this lightning load, HVAC system, and other things within the same generating plant it is being covered by 70. So this picture I think also I took from handbook as well. So some electrical equipment within the same area of generating facility might or might not be covered by the 70. So let's do some Q&A. Which location does NFPA 70E covers? This could be some workshop. Yeah, 70 we're going to cover this thing. This is we are testing in some construction and general industries. The 70 will going to cover this one. Other part, airplane, cars, trains, and any movement type of the ships, a moving house. Those things is not covered by the 70. Right. Which of the following are covered by 70? We will going to do some exam type questions, 2 to 3. If you want to refer to scope 90.2, you can refer to the standard to give the answer. Yeah, D is the right answer. Which of the following are covered by 70? Sorry, installation used by electric utility as a machine shop. A is the right answer. Installation of conductor that connect to the supply of electricity. So it's basically the service point it is talking about. A is the right answer. Installation on property owned or released by electric utility for generation. This is not covered. C is also not covered. D is right. A and D are the right option. A and D. Any question on this one? All good. What does NFPA 70E apply to? Another question, same question with different options. The utility power grid is not covered by 70, so A is not the right answer. All employees exposed to electrical hazard during the construction of building. Yes, 70 covers the general industry and construction industry. B is the right answer. All employee exposed to electrical hazards on board of US naval ships are not covered. So it's not the right answer. Only employees exposed to electrical hazard who are designated as qualified person. This is also not the right answer, because 70 talks about both qualified and unqualified persons. So it is not only for employees who are exposed to electrical hazards. So D is also not the right answer. So only option is option number B. D is the right one. Does this make sense? Any questions on this one? All good. Which of the following is covered by 70? Question is same, options are different. Just go through. These are some of the real exam questions which have happened in previous years. Right, for this one, which of the following is covered by 70E? The installation of conductor that connect to the supply of electricity in an office building used by electrical utility installation. Electric utility administration staff. This is the right option. C is the right option. Right, the characteristics of being qualified and unqualified are task dependent. What's your opinion? Yeah, basically it's task dependent. One person is qualified for one task, he could be unqualified for another task. So this is the right option. Next one, incident energy increases as the distance from the source decreases. What's your opinion on this one? Just a second. Yeah, the answer is correct. It's like this. Okay. Here the presentation went. Right. So some few words before closing today. So now we have taken an holistic approach of electrical safety in our workplaces as per the 70E requirements, how 70E can help us. So some important points, what you will be doing as a CSP holder in your organization beyond NFPA 70E. So we have discussed these type of the initiatives or the project, if not being in your organization, you can start those things like calculating when the asset will going to fail, what is the current level of the assets. You can introduce different type of the technologies to know the asset of what's the current health of the asset and when it will going to fail. You can go for some proactive asset replacement projects before assets actually fail, because you will be knowing what will be the condition of the asset and when it will going to fail, and what will going to happen when this asset fail, whether it will going to fail without causing any issues or any problem to the people who are working, or it can cause some catastrophic failure. So you can communicate that why it is required to introduce technologies in your organization, because asset will not going to talk about itself. You have to introduce, you have to do some innovation, you have to bring some technologies to perform those testing things in order to know what is the health of the your asset and when it will going to fail. So it's more about bringing some data analytics innovations in your organization, and predicting which of your assets are in red category, which need to replace, otherwise they will going to cause some serious problem. Other assets which are deteriorating or moving towards that red zone in next 1, 2, or 5 years. So what type of the maintenance strategies or other type of the strategies you have to adopt for these assets? For the other assets which are in white zone or in clear zone, what type of the strategies you should adopt for them? So those type of the innovative projects you can be involved in it. And also you can be involved in capex controlling, capital expenditure controlling. This is what we are doing as a part of our asset management strategy. So you know which assets will going to fail, what will be their consequence of failure now. So what type of the capital you have to invest in those assets right now. So what budget you should have. So if your organization is not providing you enough capital expenditure or capital budget for asset replacement, you can talk to your management that the risk will going to grow over the period of time. On the other hand, if your organization is providing you enough budget so that you are meeting the threshold level of the risk, then it's fine. And on the other hand, if you are increasing your capital expense or capital budget, then it will surely going to decrease your capital, decrease your risk over the period of time. So if you don't adopt those things, then it can lead to some quite catastrophic failure of your assets. In New Zealand, they are using the HSCQ people are basically part of the decision making for asset replacement. So here you can see that they have forecasted for next 5 years or 10 years how much asset they will going to replace based on their poor asset health. And poor asset health means that those assets are basically functional, but they are replacing those assets because of chances that it might cause some impact on the humans or the employees who are working around. So they are basically projecting the capital expenditures for next 10 years, how much they have to invest on the replacement of those assets. No, in 70 it's not about the asset management, but as I told you initially in this module number 1, that we will going to extend the 70E concept into the asset management as well. So I'm just trying to link it. It's nothing like it's not focusing on 70E thing. Okay, so it's like that. If you have a CSP, so what changes you can bring in your organization. So these are some of the examples with which electrically safety professionals and asset management people together are doing in their organizations. So what are asset replacement criteria in your organization currently, and what will be your role of whether you can provide your input into those asset replacement criteria? And if being a CSP certified, you can provide your input in developing those criteria. Who is controlling the risk-based asset replacement capex in your organization? It is with maintenance department, or it is with finance department, who don't understand about the risk, who don't understand about what will going to happen if they delay this this financing. So this capex should be sitting with asset manager or person who has understanding. So after doing the CSP certification, you people can go into the direction of the asset management as well, where the asset manager responsibility is to look for the assets from the initial phase to the last phase, and he's taking risk-based decisions. So his responsibility is also to look for the risk which are there in the organization, and to develop the strategy. So what role you will be having, or what are the challenges you will be facing? First thing is about the change management. You will be developing some new policies, procedures, and other things that will require your management of change approach. You will be seen as a subject matter expert, having an holistic view of electrical asset lifecycle activities and the system. You will be involved in the development of the electrical safety program, which is our next topic in module number 2. Training and development of personnel who are exposed to electrical hazard, auditing your electrical safety program, initiating and leading innovative projects, which some examples I have shown. So after doing the CSP certification, you can also act as an external auditor, consultant to multiple organization as well. So these type of the things or the career path you might have in future. Myself, I have been involved in training and development of multiple organizations. So if I show you, so these are the people currently I have trained globally. Those are the certified people, and this is a small list of clients which I have served remotely. I've not conducted since 2019 physical training, because when I was in Saudi Arabia, I used to conduct as a freelance training by at in different hotels, which has been organized by some organization. So you will be having a freelancing opportunities as well. Most of the training organization will going to contact you. So these are the some organizations which I have the clients which I have served till 2023 start. I've not updated this list up till now. No, I've not trained people from Saudi Aramco directly, but there was one person recently who got the training. He was working as a contractor in Saudi Aramco. Right. So summary of module number 1, what we have covered in this probably 12 hours up till now. Root causes of electrical incident at workplace beyond NFPA 70. We look into arc flash and arc blast even, and we discussed that there could be reason due to 70E and 70B as well, and as well as NEC. We have seen the purpose of NFPA 70E, NEC 70B, 70, IEEE 1584, OSHA relationships, electrical safety wheel, electrical asset life cycle, essential elements of 70, so scope of 70, hierarchy of risk controls, and role of electrical safety specialist CSP in your organization and beyond. So this is by this we have completed our first module, module number 1, and we will be starting module number 2 inshallah, in our next class. So now it's your turn, because we will be moving at a considerable pace from now onwards. So just go through initial 14 pages of the standard which we have covered up till now. Okay, so we have discussed those 14 pages, along with we have discussed some annexures up till now. Just spare some time to go through them. We have discussed annexure C, limits of approach of boundary. We have discussed annexure K, general categories of electrical hazards, right? So two annexure have been discussed. If you feel like you can read this annexure Q as well. So it's up to you. Right. Any questions up till now? All good. Right. See you all in the next class. Assalamu alaikum.
Walaikum salam, sir. Thank you.